Maupay nga aga sa iyo nga tanan. Welcome to my channel. Our topic for today for integral calculus, exponential function formula, EF. Exponential function formula. Okay. Exponential function is in power form with a constant base and the exponent contain the variable. Okay. So our exponential formula, integral of e raised to u du is equal to e u plus c. So this is our fourth integration formula. Second one is integral of a constant u du equal to a u over ln a plus c. So this is true where your a is greater than 0 and a not equal to 1. So this is our exponential formula. So these two formula is derived by taking the inverse of the differential of each exponential function e, u, and a constant raised to u respectively. So we already have, I think, 5 formula. 2 forms of our formula. Okay, let's proceed to next slide. Okay, so before we proceed to our example problem for exponential formulas, let's recall and list down the useful indefinite integral properties and the list of integration formula. As you recall, if you go to our first property, number 1, as you recall, this is du plus dv plus dx is also equal to integral of du plus dv plus dx. And for your second properties of a constant, which is we carry out to the other side of the integral sign the constant. And number 3 properties, show properties of your constant. Okay, so the reciprocal, the derivative of your constant, e du. So these are 3 properties. About for formulas. So for our formula number 1, we have the derivative of the integral of the derivative, which is equal to u plus c. This is our first integration formula. Second is your power formula. A raised to n du equal to u n plus 1 over n plus 1 plus c. So this is true when your n is not equal to negative 1. So power formula, if we replace just for negative 1, a du over un. This is also a power formula. It's only the negative form. So n minus 1 u raised to n minus 1 plus c. This is true naman if your n is not equal to 1. So, this is your power formula. For our third formula, you have the logarithmic formula. You have du over u equal to ln absolute of u plus c. This is our logarithmic formula. For our fourth formula, exponential, ef is to u du equal to au plus c. And the fifth formula, exponential, constant raised to u du equal to au ln of a plus c. So this is your exponential formula. We have two for power formula. Call them, we can call it acronym power formula A and power formula B. For EF naman, for exponential, since they are two, we can call them EF A and exponential formula B, or we called it formula 5, 4 or 5. Okay, I think we're ready for our sample problem. Okay, so let's proceed to the next slide. Okay, example number 19. Evaluate integral of e raised to 4 theta plus 1 d theta. You can check your workbook on page 37. Page 37. Example number 19. So our solution for this problem, for this function, is we need to apply our property number 3. Property number 3. We need to determine the correction factor. So we let u equals to 4 theta plus 1. So derivative of your for theta is 4. So your d theta is equal to first derivative of your reciprocal of your first derivative of your constant plus du. So finally, your d theta is equal to 1/4 du. So now, we apply our correction factor to the function. So, integral of e for theta plus 1 d theta equal to integral of e. Replace our 4 theta plus 1 by u and apply your correction factor du. Okay. So property number 2, constant. So we move our constant carry out to the other side of your integrand. So this form, we can apply our property, our formula number 4, our exponential formula letter A. So what is our formula for letter A? AU du is equal to AU plus C. Okay. So let's integrate. Constant na A1. Okay. So AU plus C. So we recall we recall the value of our u, which is 4 theta plus 1. Finally, your final answer is A, 4 theta plus 1 plus C. So that is your final answer. Okay, so let's move to our next example. Can be found in your workbook, page 38. So page 38. So example number 20, evaluate the integral of 2 dy all over 3 raised to y. Okay, again, our solution. First thing, we apply our property number 2. So the constant. And then followed with property number 3, our correction factor. So we let u equal to y, negative y. So how come it become your negative y? First, we need to simplify our equation for our function. So 2 dy equal to 3 raised to y. Okay, so applying property number 2, your constant will be dy over 3 raised to y. So we rationalize, we eliminate fraction 2, 3y, negative y, dy. So your u is equal to negative y. It's clear. So now, if you're going to get the first derivative of your negative y, that is only negative. Okay, so your dy is equal to the reciprocal of your first derivative of your du. So 1 over negative 1 du. So that is dy is equal to negative du. So finally, we can apply our correction factor here. 2 integral of 3. So a negative y, we replace it with u. And we can apply our correction factor dy. Negative du. Now, du, constant negative, negative 2. Integral of 3u du. Now, we can apply our exponential formula number 5. So, apply EF 5. So, what is the formula for EF 5? A u du equal to au over ln a plus c. Okay, apply your formula. Negative 2 quantity 3 raised to u over ln of 3 plus c. Okay. So we recall the value of our u now. Negative 2, 3 raised to negative y, ln of 3 plus c. And still we can rewrite this. Okay, so put it there. Okay, so negative 2, then negative y, we make it to positive 1, 3 raised to y, then ln of 3 plus c. So that is your final answer for number 20. Okay, number 20. Okay, let's proceed to our next example. Example number 21. Example number 21, you can find it in your workbook, page 35. Page 39, sorry. Okay, so let's evaluate the integral of quantity e raised to x plus e raised to negative x to dx. Okay, so our first approach is to simplify the given function. E raised to x plus e negative x squared dx. So we expand our function. So this is equal to e raised to 4x plus 2a 2x plus 1 all over a raised to 2x dx. So we can apply cancellation here, cancel here, and finally e become only 2x plus 2, and here we can plus reciprocal e negative 2x dx. So now we can apply our property number 1 and property number 3. Okay, so let's continue. Integral of e 2x plus 2 plus e negative 2x dx is also equal to a 2x dx plus 2 dx plus integral of e negative 2x. So we apply our first property. Now we can apply our property number 1 here. For the remaining two terms, we can apply property number 3. Okay, let's continue. So this is obvious that it will be your 2x. So we focus here. So we let u equals to 2x. At this side, we let u equals to negative 2x. So first derivative of 2x is 2. First derivative of negative 2x is negative 2. So your dx is equal to the reciprocal of your first derivative of your du, which is equal to 1/2 du. It's your dx. Also here, your dx is equal to first derivative of your reciprocal du. Finally, your dx is equal to negative 1/2 du. So here, we can apply our correction factor to our term. Let's So integral of e, replace it with the u, and apply our correction factor. 1/2 du plus 2x plus, apply our correction factor, e raised to u. Apply our correction factor, negative 1/2 du. Finally, so 1/2 au du plus 2x plus negative 1/2 au du. So we can apply our exponential formula number 4. So that is your integral of au du is equal to au plus c is au. Okay, so finally we can rewrite our final answer. So that is 1/2 au plus 2x plus negative 1/2. So we'll replace this with negative. Negative 1/2 au plus c. Then we recall our u value. Okay, so 1/2 a, this is 2x plus 2x minus 1/2. Recall the value of your u in the other side as negative 2x plus c. So that is your final answer for example number 20. Okay, I hope it's clear. So let's do some correction here. This is equivalent to AU, our number 4 formula. Okay, so let's move to our next example. Example number 22 on page number, what page is this? 40 in your workbook. So example 22 can be found in your workbook, page 40. Okay, evaluate integral of sine 2x quantity e cosine 2x dx. Okay, so we apply our property number 3. We determine the correction factor. So we let u equal to cosine 2x. So first derivative of your cosine 2x is negative 2 sine 2x. So your dx now is equal to the reciprocal of your du. So finally, it's 1 over negative 2 sine 2x du. Okay, so we apply our correction factor. Solution integral sine of 2x e cosine 2x dx. So by applying our correction factor, sine 2x e raised to u, then our dx is 1 over negative 2 sine 2x du. Okay, so let's do some cancellation here. So 2x sine 2x, remaining is negative 1 half. Okay, let's move it to the other side since it's a constant. Negative 1 half integral of e u du. Okay, so we can apply our property number 4 again. So exponential formula number 4. So integral of eu du is equal to eu plus c. So we will apply negative 1 half au plus c. Then recall your u, cosine 2x. So finally your answer e cosine 2x plus c. So that is your final answer for your example number 22. Okay, let's move to example number 23. Example number 23 can be found in your workbook page 40. Okay, so the problem is evaluate the integral of e x squared plus 2x dx. Okay, so for our solution, we apply our property number 3, determine the correction factor. So we let ru equal to x squared plus 2. First derivative of your u is 2x. Your dx is equal to reciprocal of your first derivative of your du, equal to 1 over 2x du. So we apply our correction factor. Integral of e raised to x squared plus 2x dx equal to integral of e. We replace x squared plus 2 by u, then 2x, then apply our correction factor, 1 over 2x du. So do cancellation again. Cancel 2x, 2x. The remaining is your constant 1. So du, au du. I think we can apply our formula. Exponential formula number 4. eu du equal to eu plus c. Okay, so eu plus c. So recall u, which is x squared plus 2. Finally, your answer is e x squared plus 2 plus c. So that is your final answer. Okay, let's move to another example. Example number 24. Evaluate the integral of 5 raised to x dx. So you can find this sample problem in your workbook on page 41. Okay. Solution. So we use the property number 3. Determine the correction factor. So we let u equal to x. So first derivative of your u, 1. So your dx, reciprocal of your u du is equal to 1 over 1 du. So we have a correction factor of 1. Apply 5x squared dx is equal to 5 integral of 5 u. Apply our correction factor dx du. Okay, so integral of 5u du. Okay, so we can apply our exponential formula number 5. Au du is equal to au ln of a plus c. So 5u over ln of 5 plus c. So we recall our u is equal to x. Finally, your final answer is 5 raised to x over ln 5 plus c. So that is your final answer for the problem integral 5 raised to x dx. Okay, let's move to another example. This is your last example. Can be found on page 41. Okay, evaluate the integral. So you can find it in page 41. Evaluate the integral of 3 raised to y over 4 raised to y. So before we apply our property, we need to simplify first our function. Solution integral of 3y 4y dy. So property of exponent, common power, 3/4 over y dy. Okay, so we already have this form, so we can apply our exponential property number 5. Integral of au du is au ln a plus c. Okay, apply our property, our formula. So if we're going to apply, our a is 3 over 4 over ln of 3 over 4 plus c. So we simplify the formula. Here, we can apply some logarithmic property. So that would be ln 3 minus ln 4. This is still y, okay? This is still y. Now, plus c, we distribute y again and simplify further. So this is 3 raised to y 4 raised to y over ln 3 minus ln of 4 plus c. So we move our denominator na siya. Finally, your final answer is 3 raised to y over 4 raised to y ln 3 minus ln 4 plus c. So that is your final answer for your example number 25. Okay, for your exercise number 3, solve the following exponential function You can visit your account in Moodle, submit your solution and your answer using the standard exercise form. So that's all for today. Thank you everyone and have a nice day.